Hi, Saurav here, and welcome to SoCode, your go-to channel for mastering dynamic programming and acing those top MNCs interview. So in this video series, we'll deep dive into the world of DP, focusing on 15 most crucial DP questions that will solidify your fundamental and empower you to solve DP problem with ace. Let's jump to the very first and one of the most important DP problems. Through this problem, we'll unravel the true essence of DP. So are you ready? Let's kick off this journey towards becoming a dynamic programming pro. Get your coding gears on and let's delve into the world of dynamic programming. Okay, so now let's try to figure out the problem statement. So what we are given, we are given an integer n, and that n represent the number of stairs, and we have to figure out what is the distinct way to reach the top, with one condition that the person can only take one step at a time or two step at a time. So let's say this is a person Ram which wants to climb to the top of the staircase. So what is the path he can take? So what he can do is he can go to the step number 1, then he can go to step number 2, and then he can go to step number 3. So what will be the path look like for Ram? So let's say he have started from start, he would have gone to 1, then 2, then 3. So this is one way he could have reached the top. What is the another way he could have reached? So let's say this Ram can also take two steps at a time. So let's say he have taken the step at starting and he would have taken the one step at last. So how this would have looked like? So the path would have looked like S1, not 1, he won't go to 1, 2, and then 3. So he would have directly gone to 2 and then 3. So this is another way he could have reached the top. What is the other way he could have reached the top? Let's say he would have taken step number 1 first and then he could have directly jumped to step number 3. So let's say he would have gone to step number 1 and then skip 2 and reached 3. So this is another one way. Is there any other possible ways in which Ram can reach the top? If you see, there is no possible way right now to reach the top. So what is the total number of ways he could have reached the top? There is total 3 number of ways he have reached the top. So this is what we need to return. Hope you have understood the problem. Okay, now let's try to solve this problem using dynamic programming. Don't worry if you are unaware of what dynamic programming is, because by the end of this video, you'll have a basic understanding of what dynamic programming is. Okay, so to solve any dynamic programming question, what we usually do is we try to break the problem into sub problems. So let's say a very complicated problem is given. What we can do is we can see what is the smallest or what is the simplest problem we can solve. So let's say in this example, we have given that is n equal to 0. That is how many ways are there to reach the top if there is no stairs at all. Okay. So if there are no stairs, then total number of ways to reach the top is will be 1. That is don't climb these stairs at all. Okay. So if there is no step, it will be 1. Now let's see what will be the total number of step ways to reach if there are one step. So let's say this is Ram and he wants to reach the top. So he could have taken the step number 1, that is 1. So what is the total number of ways? There are just one number of ways to reach step, that is directly go to the step 1. Okay. So now let's see if there are two steps and we have to reach the top. So what Ram could have done, he could have taken step 1 and he could have taken step 2, that is one way, or he could have taken step 2 directly, that is another one way. So there are total two number of ways to reach the top if there are total two stairs. Okay. So now let's say what is the number of ways to reach the top if there are three number of ways. This is an important thing. Okay. So what we already know is we already know this part of the problem. Don't we already know? Because we have already calculated what is the total number of ways to reach the top of the stair 2 if there were two steps. What was the total number of ways? There were total two number of ways to reach here, to reach to this point. Okay, and what was the number of ways to reach to this point? If this was the top, there were, if you see total, there was only one number of ways to reach to this point. Okay, there were one number of ways. So now Ram had to go to here, and not to two stairs and not to one, but he have to go to stair 3. How he could have reached the stair 3? He could have reached the stair 3 from either step 1. From here he could have reached here, or from here he could have reached the top. Are there any other way Ram could have reached this top of the stairs? No, right? Because if you see, he could only take one or two steps at a time. So either he would have come from jumped from here, or he would have jumped from here. So but we already know that there are total one number of ways to reach one step, and there are total two number of ways to reach two steps. So what he could have done is to, so let's say, how many ways are there to reach step 3? This dp of 3 represent what is the number of ways to reach if there are total 3 steps. This is nothing but number of ways to reach 2 step, that is 2 itself, plus number of ways to reach 1 step. Hope you are clear why I have written this. Okay, now let's try to generalize this formula. Let's say we want to calculate number of ways to reach ith step. So number of ways to reach any ith step is the number of ways to reach the I minus 1, that is previous step, plus number of ways to reach I minus 2, that is, okay. So this is the formula we have derived to solve this problem. So what we have done, we have broken this very complicated problem to reach the top steps to sub problem, that is, solve for this I minus 1 and solve for this I minus 2. We would have got number of ways to reach the ith step. Okay, so what does this d of I represent? D of I represent the number of distinct way to reach the ith stair. So what would have been the naive way to solve this problem? The naive way to solve this problem was, let's say Ram want to reach the, this is Ram and he wants to reach the top of the stair 1. He would have calculated all the possible ways he would have reached this step. Again, let's say he want to reach the top of stair 2. He would have done the same thing. He would have started from the bottom and he would have calculated till this point. And similarly, if he want to reach the step 3, he would have calculated all the possible ways to reach the step 3 from the very start. And similarly, let's say if he want to reach the step 4, he would have done the same thing, that is, start from the very start. And for the step 5, he would have done the same thing, that is, start from the very 5. This would have been a naive way, and this would have increased the time complexity also. But instead what we did was, like, let's say we want to calculate the number of ways to reach here. We already know what is the number of ways to reach here and what is the number of ways to reach here, and we just added the product. So what we did was, we solved this subproblem only once, and we stored it in the dp array, and this TP array would have given me the number of ways to reach the highest tier, and we would not have to again start from the very bottom. So giving a very formal definition what dynamic programming is. So dynamic programming is about breaking down a big problem into smaller subproblems and solving each subproblem only once. This is important. Here we are solving the subproblem only once, that is, and we are storing it somewhere so that we don't have to calculate for it again and again. So by storing this subproblem, we have avoided the redundant calculation and make the overall problem more efficient. So what will be the time complexity to solve this problem, the time complexity to solve this problem is big O of n. I'll discuss this when we code why it is big O of n, because will be only iterating the loop once. Okay, and what will be the space complexity to solve this problem? The space complexity is, since we are you will be using this dp array of size n, it will be big O of n. If it's not clear here why it is big O of n, both of this, it will be clear once we write the code. So without wasting any time, let's jump to the coding page. Okay, I'm in the coding screen now. Let's try to code it. It will be a short 5 to 10 lines of code. I'll be using Java. You can use any language of your choice, but the approach will remain same. So let's first define a dp array. This will be of size n. It will be n plus 1 because it's a 0 base index. Then what is the number of ways to reach 0 step? That is 1. What is the number of ways to reach 1 step? It is again 1. We have discussed these two things. Now let's try to fill out the other values. We'll start from 2 because we have already figured out the first two values, and we'll run it till n. We just have to use the same formula what we have discussed. dp of I will be dp of I minus 1 plus dp of I minus 2. Yeah, that's pretty much it. That's the code. We just have to return the dp of n. That is, dp of n represent number of ways to reach the nth step. Yes, that's it. Now this should work. Let me try to submit it. Okay, hope you have enjoyed the video. Don't forget to leave a like and do consider subscribing. Have a good one. Bye.